show me how to do everything I need to do on the calculator on the same.
Can I go to my locker?
Yes, possibly. So we're going to look at 41 first and then go on from here. Now, one of the things we can say with 41 that's going to help us out is that whenever there's a variable in both exponents, or when there's a variable in the exponent on both sides of the equation, we know we're going to have to use the one-to-one property. We're going to need to rewrite 512 and 1/8 so that they are the same number. We need them both to the same base. So it'd be helpful if I could rewrite 512 as 8 to a power. So if we look at the calculator, we can try seeing 8 times 8 is 64. And if we multiply 64 by 8, we do get 512. Or we can say 8 to the third power is 512. So we can rewrite 512 as 8 to the third. In our 1 over 8, we can move the 8 up to the numerator. And it's going to take its exponent of 1 from being positive to negative. Because whenever we move a number from the numerator to denominator or denominator to the numerator, the exponent changes from negative to positive or positive to negative. So, any questions on how we got the bases to be the same? So the next thing we need to do is multiply our exponents out. So 3 times 5x is going to be 15x. 3 times negative 1 would be minus 3. Here we're going to distribute the negative 1. Negative 1 times 4 is going to be positive 4. And negative 1 times negative x will give us plus x. Now whenever the bases are the same, the exponents have to be also. So what that's telling us is that 15x minus 3 is equal to x plus 4. All I did was flip the 4 and x, and it will give us the exact same thing. Now at this point here, we just need to solve for the value of x. So the first thing we can do is subtract x from both sides. 15x minus x is going to give us 14x. Minus 3 is equal to 4. Then the next thing we can do is add 3 to both sides. So 14x is equal to 7. And last but not least, we can divide both sides by 14, telling us x is equal to 1/2. So we get the fact that x is equal to 1/2. And that would be our answer. Any other questions on this here?
If I fail the test, it's just
We'll see where you're at after the test and go from there, because there is the makeup points. Any other questions on problem 41? 160 times 2, 320. Questions on 43.
sure do it.
So with this one here, we need to start off by getting e by itself first. So we need to get the, yes. So we need to get e by itself. And the first thing we can do to get e by itself is to add 7 to both sides. Because negative 7 plus 7 is 0, telling us that 2e to the x is equal to 12. Now e is not by itself, so the next thing we need to do is divide both sides by 2, telling us e to the x is equal to 6. After adding 7 and dividing by 2, we do get e by itself. So the next thing we can do is apply the natural log to both sides. And ln of e to the x, well, the x can move up front, x, And the natural log of e is 1, so it's gone. Telling us ln of x is equal to the natural log of 6. And at this point here, we can plug this into the calculator. So we can pull the calculator up and say ln of 6 and hit enter, and we are told that it's 1.7917594269. Or if we go to 3 decimal places, it'll be 1.792. And that there would be our final answer. Any other questions on this problem here? Questions on 44 or 45? 44. So again, just like with the last one, we do need to get e by itself. So the first thing we can do is subtract 9 from both sides. And it's 6e to the 2x plus 1 is equal to 6. Now the next thing we can do is to divide both sides by 6. And when we divide both sides by 6, we get e to the 2x plus 1 is equal to 1. Yes, since we do have e by itself, we will apply the natural log to both sides. On the left-hand side, the exponent would move to the front, giving us 2x plus 1. Now ln of e simplifies to 1. And on the other side, we have the natural log of 1.
Take away 1. Oh, so that means we got 0?
So the ln of 1 is inside the parentheses, so it's ln of 1 minus 1. And then we would divide both sides by 2, telling us x is equal to the natural log of 1 minus 1 over 2. And if we type that in, we will get negative 1/2.
So how did you do the ln thing?
So to type this in, we can go alpha y equals inner
Alpha y equals.
to get the fraction.
Oh, I see it.
Then we can go ln of 1 minus 1 all over 2. And we get negative 1/2. So the answer for this one here is negative 1/2. Any questions on any of this here? Questions on 50 or 45? So the first thing we need to do is to get the x out of the exponent, and we can do that by applying what log of what to both sides. 7. Because we can move the x out front because of our properties of logarithms, which leaves us with log base 7 of 7. And anytime the base and what's inside are the exact same, it simplifies to 1. So this is gone, leaving us with just x. On the other side, we have log base 7 of 3. And at this point here, we just need to type log base 7 of 3 into the calculator. And to do that, we can go math up to log base and hit enter. So we're saying it's log base 7 of 3. And log base 7 of 3 is 0.564575031, Or if we're going to 3 decimal places, it's going to be 0.565. And that's all we would need to do for this here. Any other questions on these two here, 44 or 45? Questions on 46 or 47?
When it says log like on 48, can we just type those in?
So we can look at 48. Now, so log of 38 is in parentheses, but we can't type log of 7x plus 3 into the graphing calculators or yellow calculators because it needs a value for x. But since the logs are the same, these logs are the exact same, it means what's inside has to be equal. If the logs are the exact same, what's inside has to be equal. So 7x plus 3 has to equal 38. Now at this point here, we can solve for the value of x. And the first thing we can do is subtract 3 from both sides. These will cancel, telling us 7x is equal to 35. Then the next thing we can do is divide both sides by 7.
So that's literally all you do?
Yes.
That's the easiest thing for
Any other questions on 48? Questions on 49? Mm-hmm. So we could subtract 12x from both sides to get all the variables on the same side. Because 12x minus 12x is 0, telling us negative 9 is equal to negative 9x. And that's it. Any questions over any of these here? Yes. Because as long as the logs are the same, what's inside is going to be equal.
So the same with the ln?
Now, for this here, it's understood that the base is 10, yes? So if I put both sides to the base 10, 10 to the log, well, the 10 and log would cancel each other out. The same with the other side, leaving us with 12x minus 9 is equal to 3x.
So all you do on the ones above it,
So here, right, if I put e to both sides, e to the ln is gone, leaving us with 3x plus 2. Here, e ln gone, 4x plus 5. Or sorry, no, that should be minus. That should be minus. Yes. So we could subtract 3x from both sides first, telling us 2 is equal to x minus 5. Add 5 to both sides, telling us x is equal to 7. Because if the logs are the same, then the exponents, or what's inside, has to be the same as well. So if the logs are the same, what's inside the logarithm has to be the same as well. 46, well, to get the exponent, or get the variable out of the exponent, we're going to apply log base to both sides. Because here the exponent would move to the front, leaving us with log base 11 of 11. And whenever the base and what's inside the logarithm are the same, it simplifies to 1. Now at this point here, we need to solve for the value of x. So the first thing we can do is subtract 2 from both sides, telling us that 6x equals log base 11 of 38 minus 2. And last but not least, we would divide both sides by 6. Telling us x is equal to log base 11 of 38 minus 2 divided by 6. Now at this point here, we would type it into the calculator. So we can go alpha y equals enter to get the fraction. So what's inside the log cannot be negative, but since we started with a exponent, that's fine. So negative 0.805.
What?
So we can do that first. Make sure that's divided by 6. So making sure to put a negative and minus instead of a negative, and then dividing. Because if the way you had it originally, it was the negative was making it multiply, and then it was just dividing by that. So negative 0.0805 is what our answer should be. Yes, because, yep, most of them will tell you to approximate to 3 decimal places. If you're not sure of how that works, just give me as many as you want. So any other questions on these two here? Questions on 46 or 47? Questions on 50? Since the logs are the same, what's inside has to be the same as well.
For some reason I can't find my 50. Well, it's like.
Yep. Since it is a quadratic, we need to get everything on the same side of the equal sign. So we can add x to both sides. Because negative x plus x is 0. On the other side, negative x and x will cancel out, telling us that x squared minus 6 is equal to 0. Since we don't have a middle term, we can use the square root method, which is going to be to add 6 to both sides first, which will tell us that x squared is equal to, now we would, x is equal to, because it doesn't have a nice square root.
What are you logging now?
So the original problem is this here. Now we do need to make sure that what's inside the log cannot be negative after we plug it in. Now the one that normally doesn't work is the negative. So if we looked at log base 2 of negative square root of 6 squared minus negative square root of 6 minus 6 should equal log base 2 of negative square root of 6. And this is the one that normally leaves us with a negative inside the radical, or inside the logarithm. Now, if we wanted to at this point, we could type this whole thing in the calculator to see, does it give us a negative number or 0? Now,
This one's mine. I just mine. Over the head.
if I type this in, is it going to be negative?
Probably.
Okay. So to check it, all I need to do is grab a calculator and type it in exactly as we have it. We don't need the log. But we can say parentheses, second square root of 6, close parentheses squared, minus negative, what? Typing this literally in the calculator to see, is that negative? No, so it works. That's all we're trying to figure out. So that gives us a positive equals log base 2. Here a negative and negative make a positive square root of 6.
So all you have to do is square root of 6.
So it tells us that negative square root of 6 works. Now if we check positive square root of 6, so in each one of these spots, instead of having the negative, if we have it as positive, we want to see, does it still give us a positive? So parentheses, second square root 6, squared, minus and here we get a negative. So this time it doesn't give us a positive, it gives us a, which means the positive case in this one doesn't work, but so x equals negative square root of 6. Yes?
Hey, I'm going to say that part.
That's too late. I got it.
It's late.
Wait, hold on.
Any other questions on number 50? Questions on 51 or 52? Or one of these two that we want to look at?
No, I did not. Hey, what did the fish say?
What? Hmm?
That's very good.
So which one do we want to look at, 51 or 52? So to get the variable out of the logarithm, we need to put both sides, guys. We need to put both sides to a certain base. So here we're going to put both to the base of 7, because 7 to the log base 7, these will simplify out, leaving us with 4x plus 9 is equal to. So on the other side we have 7 squared, and this here does simplify to a nice number, because 7 squared is 49. After we apply the base of 7, now we just need to solve for the value of x. So the first thing we can do is subtract 9 from both sides. And if we subtract 9 from both sides, these will cancel out, telling us 4x is equal to 49 minus 9 is. Divide both sides by 4, telling us x is equal to 10. Yes?
Oh,
Yes.
if you follow her anywhere,
All right, guys, let's focus back in here. Any other questions on 51 before we look at 52? Now,
this one's too easy too. Let me go up there and do it.
so what would we do first?
E on both sides.
We would put both sides to the base of e, because e and ln will cancel each other out, leaving us with 6x minus 2 is equal to e to the 7th. Now, e to the 7th will not simplify to a nice number, because e is an irrational number, so we'll leave it as e to the 7th till the end.
Plus 2.
I can add 2 to both sides, so in a 6x is equal to e to the 7th plus 2. And lastly, we can
Divide by 6.
telling us x is equal to e to the 7th plus 2 over.
Now we gotta solve 30.
Now we just need to plug it in the calculator.
Do that.
So e, so we can go second ln to get e, 7th plus 2 So since I didn't put a fraction, I can go on and do e to the 7th plus 2, which will give me the value of the numerator. And at this point here, we just need to divide that number by 6. So we get 183.1055.
See, now that does not make sense. It's got me at 1350. Wait, let's see what it is. Yep. Yeah, that's. You were on the third.
No, I divided it by 2, not 6.
Oh, I was right. You were wrong.
Yeah. Divided by 6 should be 183.106.
Oh, got it wrong still. No. Listen, I want to figure it out. So, second ln. Okay. We put in a 7.
Make sure to get out of the exponent by 6. Because I think on the previous one you did e to the 9th divided by 6.
No, what I did was I kept it in the exponent. So,
And then plus 2 divided by 6. Yep.
so maybe you should redo that.
So, guys, again, even on cases like that, make sure to have this written down first, and then find the answer.
Yeah, mess up on calculator. I do all the work right, but I still get pretty good points.
If this is not right, I will look back to this before I start marking points off. Okay? So if you had it down as e to the 7th plus 2, all divided by 6, okay, I know that whatever happened between here and here was a calculation error, or calculator error, not a solving error. Yes. Any other questions on these two here before we look at the next one? Any questions on 53 or 54? Because these are going to be the same as what we just did. We just have to get 54 by itself first. ln of 6x minus 4. The minus 4 is not a part of the 6x. So if we were going to solve this one here, we would first have to add 4 to both sides, telling us ln of 6x is equal to 19. At this point here, we would then apply e, because those would cancel, telling us 6x is equal to e to the 19th. And lastly, we would divide by 6. And this number is going to be quite big.
I got 2974705 Oh my gosh, I got it right. So boring.
To get the longer decimal, all you need to do is subtract this number from it, and it'll bump the decimal over. So I can show you all that here, because we could say second ln of 19 divided by 6, and we get this number here. It only gives us 2 decimal places. If I go minus 29747,050. So the whole number part of it, it bumps it over. So if you wanted to see a third decimal place, that's all you had to do. Not that it'll be needed, but we get this here. Give me 2. We don't necessarily need that. That there is close enough. Any other questions on any of this here? Any questions on any of this here? All right, let's look at 56 next. Let's look at 56. Whenever we have 2 logs being added together, we can rewrite it as a single log with what's inside being multiplied. So here we'd have log base 2 of x times 2 is equal to 3. Whenever we have one or more logs being added together, we can rewrite it as a single log of what's inside being multiplied. After this, we're going to put both sides to the base of 2. Because 2 to the log base 2 will cancel, leaving me with x times x minus 2 is equal to 2 to the third. Now 2 to the third will simplify nicely, because 2 times itself 3 times would be 8. Now on the left-hand side, we do need to distribute the x. So we can say x times x is x squared. X times negative 2 would be negative 2x is equal to 8. Now at this point here, we do need to get this equal to 0 because it is a quadratic. So the next thing we can do is subtract 8 from both sides. Okay, x squared minus 2x minus 8 is going to equal 0. Now at this point here, we can either graph it, factor it, or use the quadratic method to solve. Now if we factor this, we'll use our two sets of parentheses. Because the 8 is negative, our signs are going to be opposite. And the factors of x squared are x and x. Now we need to find the factors of 8 that are going to work for this here. So we'd have 1 and 8 or 2 and 4. For this one here, we would need 2 and 4, and the 2 would be positive. Now whenever two things are multiplied together to equal 0, one of them must be 0. So either x plus 2 is 0 or x minus 4 is 0. And then we can solve. So the first thing we can do for this here is subtract 2 from both sides, telling us x is equal to negative 2. For the other one, we can add 4 to both sides, telling us x is equal to 4. Now we can plug both of these in back into the original equation to see if one of them will give us a negative inside the log. So our first one was log base 2 of x plus log base 2 of x minus 2 is equal to 3. We are on now because we do get a negative in both parts of the log, because this would be negative 2 plus log base 2 of negative 2 minus 2 is negative 4. This tells me that x equals 2 does not work. If we did the same thing with 4, we would see that it does work, because we would have positive numbers in every spot where we have a log. Because it would be 4 and 4 minus 2. This here would just be log base 2 of 4, and 2 minus 4 is 2. And this here would work. So for this one here, x equals 4 would be the only solution. Any other questions on this one here? All right. Inequalities are the last ones we're going to look at. Questions on 57 or 58? Which one? 57? Yeah. So this here, we still need to solve for the value of x. Now to get rid of the natural log, we're going to put both sides to the base of e, because the e and the ln will cancel, telling us that x minus 1 is greater than or equal to e to the 9th. Now we need to get x by itself. So the next thing we can do is to add 1 to both sides. And that will tell us that x is greater than or equal to e to the 9th plus 1. Now at this point here, we can type this into the calculator. E to the 9th plus 1 is 8,104.084. Now, since we are dealing with natural logs, guys, let's focus in. Since we are dealing with natural logs, what's inside of the natural log or logarithms cannot be negative or 0. But since x is greater than 8,104, there's no way that this would occur. Because 0 is not greater than 8,104, this here would be the final answer.
That's pretty easy.
Any questions on 58?
No, sir.
Questions on 59 or 60? So if we look at 59, the first thing we need to do is to get the natural log by itself. So we'll need to subtract 7 first. First thing we do is subtract 7 from both sides, and if we do that, we'll get 6 times the natural log of x is less than 53. Since the natural log is still not by itself, the next thing we can do is to divide both sides by 6, telling us that the natural log of x is less than 53 divided by 6. So the first thing we need to do for this here is to get the natural log by itself. Once we get the natural log by itself, we can apply e to both sides, because e and the ln will cancel each other out, telling us x is less than e to the 53 divided by 6. So we can go second ln to get e. Then we can say alpha y equals, enter to get our fraction, 53 over 6.
You get 6,859.
So we get this here. Now, since it is less than, what's inside the natural log cannot be 0 or negative. Well, what's inside the natural log is x, and it must be greater than 0. So since it's just x, we have to add in, because what's inside the natural log cannot be negative or 0. Now, anytime we start off with the natural log and end up with x is less than a number, we need to add the restriction in. So to find the restriction, we set what's inside the natural log or logarithm to be greater than 0, solve for the value of x, and then add that in. If it's less than, and we start out with logs. If it has been an exponent, then we won't need it. Any other questions on these two here? We're going to look at one more before we're done. The last one we'll look at is 64. Now for 64, the first thing we're going to do is apply log base 4, guys, to both sides. Now, guys, on the left-hand side, log base 4 of 4 will cancel, leaving us x by itself. On the other side, we'll have log base 4 of 36. And if we type that into the calculator, we get 2.5849. Now this here is the final answer, even though we do have less than, because it's in the exponent, it's still true. We don't need to add the restriction. So that's all we're doing.